So now that we have some basic terminologies gone over, now we're just going to go over a little more of the line work that you see in the details and what they represent, as well as maybe a few more terms that may come up as we go along. So what I did here was I just took our captured horizontal and I rotated it so that way we could see how it will align and mate with the vertical members. And what I'm going to do for visual is I'm just going to draw a line showing what every line represents that you'll see on the verticals, and then we'll do the same vice versa on the horizontals. So I'll show you what I mean. Okay, so this is our horizontal, rotated. It should line up in the back to our verticals. So I'm just going to draw that line there. That's the back of our system. And you will see that the actual part of our horizontal is actually a bit smaller than the back of the system. This is correct. This is a design intent, so that way this allows for a little bit of wiggle room in assembly, and as well as die tolerances, so that this horizontal will never exceed and stick out past the verticals. So this is correct. This is on purpose. Okay. It should be 0.02, I believe, is the number that we typically have as an offset. Now I'm going to offset this line to the assembly screws. So I'm going to go to the center of our screw raceways. Okay, so that is our assembly screws. So that should align with these on our verticals, because that's representing this screw is attaching this horizontal through this screw raceway. So if I go across all the verticals, those screws should align, and that's how we locate those. I'm going to do the same for the next screw raceway. Okay, and those all should align as well. Okay, so going across. Okay, so that's how the assembly screws are located and why we see these two in a vertical view. And typically our standard is to attach with 3 screws. Okay. The next lines will be, you should see the back of pocket line. So if I go offset through to the back of the pocket, remember it's right here, the edge of the extrusion. Okay, so that's the next lines you see. Now we're showing them as a hidden line in our details. The reason for that is you see these gaskets here. Okay, these back gaskets. They have on them what we call a trim lip. This little trim lip is technically installed on top of the horizontal member, the die. So really, the back of pocket is hidden by this gasket. So this is why we show it with a hidden line. Then this line here that you see in white is an actual line representing this gasket trim lip. Okay, so if I offset my construction line to that trim lip, that will align on all of our details, as you can see. Okay, so that's why you see that solid line back here, and then a hidden line represents the back of pocket. Our standard dimension from back of pocket to back of glass is 1/4 inch. So right now, that's our standard, and that should never change. But I can only say never once, because sometimes that does change, but our standard is 1/4 inch. Okay, so same with the front. If I offset my construction line now to the face of the pocket, okay, again, it's shown as a hidden line because, again, horizontally we have this trim lip on the gasket. So you have a hidden line for the pocket and then a solid line for the trim lip of the gasket. And that's what we're seeing horizontally. Okay. Our standard dimension from back pocket to front of pocket for 1 inch glass is 1.5 inches. That's our standard. So 1/4 inch plus a 1 inch plus another 1/4 inch, gives you 1.5 inches. That's our standard. Okay, and then the next line would be the face of system. So again, I'm going to offset to this line, and again, you'll see our horizontals are purposely short. Okay, that is on purpose, that is intentional. Okay, face of system is typically at our verticals face, which is truly 7.5. So face of system is driven by the vertical face and back of system. So our vertical mullions are driving the overall system depth. So our standard is 7.5 by 2 3/4. Okay. Now on the Inviso, you'll see there's some extra lines here. Okay, these lines represent the splice of this horizontal cover, face cover. When the two units meet, we leave a gap. So I have this little ISO of a deeper cover, but the same concept applies. So you can see this cover in my vertical view. I'm looking down on it. Here's that cover, and there's those lines, which represent this finished little gap we leave. That's our standard. So we show it in our 2D details, so everyone knows that there will be a little gap from the face horizontally. So that's what those lines represent. Okay, so now that we did that on our horizontals, I'm going to pause and then we'll jump and do the same thing with the verticals so you can see how those lines align with our horizontal details. Okay, so now I did the same thing. I took our vertical detail and I rotated it sideways so we could see how it aligns with our horizontal details. Okay, so again, I'm going to start with the back of system. Okay, so you should see that same offset horizontally. The one that does not offset is the sill when it has an SRT hook. This is what we call an SRT hook, because this receives an interior closer trim, so those need to butt up nicely to the system. We don't want to have that offset here. So that's one thing that is intentional. Okay, this is our sill track, and it also butts up to the back of system. Okay, now I'm going to again go to the center line of our raceways. They all should still align. They're all the same dimensions, and they should all line up with the verticals. Okay. Now you'll see on the sill there's some extra lines here. These lines here and this line here. That represents the notch that occurs on the bottom of our vertical members. So the vertical members have to be notched to go up and over the chicken head, as well as this back leg of the sill for installation. And the notch is large enough to allow for up and down movement. Okay? Our sill typically is a wind load connection, which means the verticals are allowed to move up and down. Okay, so I have an ISO here that shows you what that notch looks like at the bottom of our vertical when it attaches to a sill. Okay. Okay. So then I'm going to keep going to the next lines, which will be again back pocket. Okay, so all that aligns. Again, 1/4 inch gasket, 1 inch glass, another 1/4 inch gasket, so 1.5 inches should be where this face of pocket is. Okay, that's again standard, and it all should align with the vertical. And then the face of system, which is the true 7.5, and again the horizontals are short. Okay, but they all should align up. Okay, so same thing on the horizontals. We're showing the pockets as hidden lines because of these trim lips on the gaskets. Okay, Okay, so that's why you're seeing solid lines offset a little bit. Okay? This sealant that you're seeing here on the horizontals and the sills, this is what we call our assembly seal, right, or joinery sill. When these two pieces mate together, we put sealant between the metal to metal. So I have this ISO here to show you when a vertical member butts up to a horizontal member, right between the two pieces, we seal all that up. Okay, so we show that in our details. And that's what you're seeing here. And here, this is the vertical, excuse me, sorry not to confuse you. And here down at the sills. Okay, so that's normal. That is going to be on all assembly details because that's how we make sure it's watertight when the two pieces get screwed together. Okay, and all that happens in the shop. Okay, this hidden line is what we call an index clip. We have an installation manual sheet now for that. So if you're curious how that works, it occurs at each vertical. That's why it's shown hidden, because it's technically beyond. And then we have our shim stack, which is plastic shims. And then we have our perimeter sealant or perimeter seal. This hatched object represents what we call our backer rod or foam rod. It's just some foam. And then this pattern represents our sealant. Okay? All right, so that's the basic overview of our vertical and horizontal alignment and what the line work is showing in our 2D details.